So, hi everyone. So, for the last module, I choose the derivative of hyperbolic functions. And then, this is the basic formulas of a hyperbolic trigonometry, which is hyperbolic of sine x is equals to e to the power of x minus e to the power of negative x over 2. Then next is the hyperbolic of cosine x is equals to e to the power of x plus e to the power of negative x over 2. Next is hyperbolic 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 sine squared x is equals to 1/4 e to the power of 2x minus 2 plus e to the power of negative 2x. And last is the hyperbolic of cosine squared x is equals to 1/4 e to the power of negative 2x plus 2 is equals plus e to the power of negative 2x. So for the hyperbolic functions, it has also a hyperbolic identities like hyperbolic of tangent x is equals to hyperbolic of sine x over hyperbolic of cosine x. And next is hyperbolic of cotangent x is equals to 1 over hyperbolic of tangent x is equals also to hyperbolic of cosine x over hyperbolic of sine x. And next is hyperbolic of second x is equals to 1 over hyperbolic of cosine x. Then hyperbolic of cosecant x is equals to 1 over hyperbolic of sine x. And the last one is the um, hyperbolic of cosine squared x minus hyperbolic of sine squared x is equals to positive 1. So this is the formula for the derivative of hyperbolic function. So we noticed that here it is like a trigonometric functions, but we have a hyperbolic sign that are included. It is almost identical to the derivative of the trigonometric functions, but here the derivative of that are positive is the basic trigonometry, which is the hyperbolic of sine, hyperbolic of cosine, and the hyperbolic of tangent. So their derivative are positive, and the under and the reciprocal is the derivative is negative. So the reciprocal is the hyperbolic of cotangent, hyperbolic of secant, and the hyperbolic of cosecant. So this is the formula. Let u is function of x or independent variable. So first is the derivative of hyperbolic sine u with respect to x is equals to hyperbolic of cosine u du over dx. Then second is the derivative of hyperbolic cosine u with respect to x is equals to hyperbolic of sine u d over dx. Third is the derivative of hyperbolic of tangent u with respect to x is equals to hyperbolic of secant squared u du over dx. The fourth is um, derivative of hyperbolic of cotangent q with respect to x is equals to negative hyperbolic of negative cosecant squared u du over dx. The fifth is the derivative of hyperbolic secant u is equals to hyperbolic of negative secant u hyperbolic of tangent u du over dx. And the last formula for the differentiation of the hyperbolic function is the derivative of hyperbolic cosecant u with respect to x is equals to hyperbolic of negative cosecant u hyperbolic of cotangent u d over dx. So let us give one example. So the given is y is equals to ln hyperbolic cosine 2x. And then for this one, we will going to use the formula for the logarithmic, the differentiation of the logarithmic function, which is the 1 over u du over dx. So it will become dy over dx is equals to 1 over cosine hyperbolic cosine 2x, the derivative of a, so our u for this given is the hyperbolic cosine 2x. So the derivative of hyperbolic cosine 2x with respect to x, it is so the answer will be the next we will do is the dy over dx is equals to 1 over hyperbolic cosine 2x. Then the derivative of hyperbolic cosine 2x is equals to hyperbolic sine 2x. Then so for this another we get, so our u for here is 2x. So we will find the derivative of 2x with respect to x. Then it will become 1 over hyperbolic cosine 2x and then sine hyperbolic sine 2x. Then the derivative of 2x is 2. So we will be combining the 1 and the hyperbolic sine 2x and 2. It will become, so first we will arrange the answer. It will become 1 over hyperbolic cosine 2x, then 2 hyperbolic sine 2x, then it will become 2 hyperbolic sine 2x over hyperbolic cosine 2x. So for this one, it has a hyperbolic identity. So this is the identity for our answer. So our final answer will be dy over dx is equals to is equals to 2. Then our hyperbolic identity for the sine hyperbolic sine 2x and over hyperbolic cosine 2x is hyperbolic tangent 2x. So you will write the identity hyperbolic tangent 2x. So this is our final answer for the differentiation of the hyperbolic functions for this module. So that will be all for this topic, and thank you.